Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 232, implement queue using stacks. So I would say it's one of the classic problems, and this question is asked many a times in very famous company interviews, and we're going to look into it today. So first we'll check out the problem statement, then we'll check out the approach which you're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is very straight up. So we'll have to basically implement a queue using stacks. Okay, so implement a first in first out queue using only two stacks. So basically, in queue we use FIFO strategy. FIFO stands for first in first out, and on the other hand, in stack we use LIFO strategy, last in first out. Okay, so we have to implement these four methods: push, peek, pop, and empty, and they have given the definition for each of the methods. With push, we will be pushing a new element to the back of the queue. With pop, we will remove the element from the front of the queue and return it. With peek, we will just see what is the element at the front of the queue, and empty will basically check if we have a empty queue or not. Okay, you must only use standard operation. Okay, I think these are basic notes. And they have also given an example which we'll be using in our case as well. So let's go to the approach which we're going to use. Okay, so starting with the example. So this is the exact same example which they have taken in the question itself. So first, we'll have to know this: queue follows first in first out strategy. Okay, on the other hand, stacks follow last in first out. Okay, so what does first in first out means? For example, in this case, if one is pushed first, when we'll try to do the pop on it, it will give one first. Okay, let's consider this one. In fact, so we have 1 and 2 in queue, and 1 was inserted first or before 2. So when we'll pop the element, 1 will be popped. Okay, but in stacks, if this was exact same condition, and we do the pop, it will pop 2. Okay, not 1, it will pop 2. So in stack, the element entered the stack later will be eliminated first. In queue, it's the other way around. Okay, so that is exactly what we're going to use. And it's just a classic problem in and the the idea behind solving this is you need to have two stacks. Okay, to implement a queue using stacks, you need to have two stacks. Okay, let's name them S1 and S2. So for push, what we will do, we will first transfer all the elements from S1 to S2. Okay, all the elements from top to bottom, and then we will add our element on top of S1. Okay, after adding the element, we will again take back all the elements from S2 to S1. Okay, so this is how we do push operation. So for push, let me write down here shift. Okay, I should so for push, we will shift all elements from S1 to S2, add element in S1, then shift all elements from S2 to S1. Okay, these will be the 3 steps for a push operation. So in this case, what it will be, for example, we have S1 and S2, and like your S1 will be treated as a queue. Okay, so whenever you'll have to say which stack is your queue or is acting as a queue, it will be S1. So we didn't had any element in S1 at the moment, so we don't have to transfer anything on S2, and we can simply add 1 in it. Okay, now comes push 2 again. Okay, and this is the situation at the moment. We have 1 in S1, S2 is empty. Okay, then what we will do, we will first transfer all elements from S1 to S2. Okay, now we will add the new element on S1. This is our S2, and at the end we will transfer the element from S2 to S1 again. Okay, now comes peak. With peak we basically just had to check what the element at the front of queue. So to do that, what you can do, you can just simply check for peak, check element at index -1. -1 basically represents the last element in the array. Okay, and pop, for pop we just have to simply do the pop operation, and we will simply use the dot pop method to do so. And when you'll do pop, sorry, I should do this. When we peaked, everything remained same. Okay, now comes the pop operation. Pop will basically remove your element from the top, and it will give you the element. Okay, and the only element remain is 2 now. And empty will basically tell if our queue is empty or not. So as you can see, we have an element in S1, so we will say no, false. Okay, for popping we will simply use pop method. Now let's check out the code for the same. So if you see here, what I have done, I have defined or initialized two stacks, stack 1, stack 2. Okay, now at the time of push operation, what we are doing, we are basically transferring all the elements to stack 2 from stack 1. Okay, so pop will basically pick elements from stack 1 and will add in stack 2. Then we added the new element in stack 1, and we again transferred all the elements from stack 2 to stack 1. Next comes pop. As I said, we'll simply use the pop method to do so. Next is peak. With peak, we wanted to check the last element added in the stack. So we can have -1 for the last index, and that's what we are doing over here. And for empty, we are just checking if the length of stack 1 is 0 or not. If it is, we will return true, otherwise we'll return false. So let's check out the test cases. So as you can see, the test case got clear. Let's submit it for further evaluation now. And the solution also got accepted. And yeah, this was the solution, guys. Thanks again for watching all the videos. Stay tuned with upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.